Hello, future engineers, subscribers, viewers, and students. There is another video as part of Beautiful and Challenge Problem in Engineering Economy. And there are 4 problems here, and I hope that through these examples, your knowledge in Engineering Economy will be enhanced further. And I hope that you can also solve problems in Engineering Economy by your own. So here is the first problem, part A, 41A. A. Find the amount of annuity whose present value is $2,500 and term is 7 years. If money is worth 6.5% compounded quarterly. And B, find the present value of an annuity whose amount is $15,000 and term is 8 years if money is worth 5%. So for part A, given the present value to find the uh, future worth of annuity. So in this problem, there's no need to compute for the annuity or the annual payments or annual amount. We just proceed directly to the bridge between the future worth and the present worth. So that is future worth equals present worth times quantity 1 plus I to the n, where n is 4 times 7 my 28 and I is equal to 0.065 divided by 4. So substitute into the formula. So F equals the amount of an annuity is the future worth. So it is equal to $2,500 quantity 1 plus 0.065 over 4 raised to 28. And that is equal to 3926.05 dollars. For part B, find the present value of an annuity whose amount is $15 and term is 8 years. So we have the same idea. I is 0.05 and N is 8. So substitute into this formula, $15,000 equals P times quantity 1.05 or 1 plus 0.05 to the 8. So solving for P is $10,152.6. Then we proceed to 41B. The buyer of a house will pay $7,500 cash and $1,000 at the end of each 3 months for 12 years. If money is worth 9% compounded quarterly, so the interest is matching with the mode of payment. So find the cash value of the house, the remaining liability of the debtor just after he pays his 10th installment of $1,000 and his remaining liability just before he pays the 10th installment. So first for the uh, cash value of the house or the present value of the house. So it is equal to P1, which is 7,500. This is cash, so this is already present worth. Then the present value of this quarterly payments of $1,000. So therefore, P is equal to P1 plus A over I quantity 1 minus quantity 1 plus I to the negative n, where P1 is $7,500, A is $1,000, I is 0.09 over 4, and that is 0.0225, and n is 4 times 12, so 48. So substitute 7,500 plus 1,000 over 0.0225. Again, 0.0225 is equal to 0.09 divided by 4. Then quantity 1 minus 1, 0.0225 raised to negative 48. 48 is 4 times 12 years. So solving for P is equal to $36,670. Then for Part B, the remaining liability of the debtor just after he pays the 10th installment. So after paying the 10th installment, the remaining uh, liability of the debtor is equal to the value at the 10th period of the 11th up to the 48th payments. And that 11 to 48 payments is the value at this 10th installment. So I'll call that F10. F10, although it is future, but if you imagine, it is the value of the 11th up to the 48 pay, up to the 48 quarterly payments. So 48 minus 11 is 37 plus 1. So there will be 38 payments. So therefore, it is A over I, quantity 1 minus 1 plus I to the negative 38. That's the formula for F10. So I hope that you understood that. That's the worth of the 11th up to the 40th payments. And it is present worth of ordinary annuity. So just you may draw the cash flow diagram. So F10 is equal to $25,363. Then his remaining liability before he pays the 10th installment. So before paying the 10th installment, I'll call that F10 left. Then it is equal to, because he's about to pay $1,000. So it is equal to $1,000 plus this remaining liability after the 10th installment. So that is 25,363 plus $1,000. So that would be $26,363. Then to part C, 21BC, we have here his remaining liability just before he pays the 10th installment. So that's the answer. Ready. So that's 41BC. Let's proceed to 41C. In return for a loan with money worth 7% compounded semi-annually, a man promises to pay $600 at the end of each 6 months for 8 years. Find the sum which he borrows. So find the present worth of this semi-annual annuity of $600. Then find his remaining liability just after the 6th payment. This is similar in sense to 41B-A. So it is after the 6th payment. So it is the value present or the value at the 6th payment F6 of the 7th up to, because the number of payments here is 2 times 8 years 16. So that's the value of the 7th up to the 16th payments. So we use the formula here just like there. So that's 16 minus 7 is 9 plus 10 plus 1. So it's 10. So P is A over I, quantity 1 minus 1 plus I to the negative n. So 600 over 0.035, where 0.035 is 0.07 divided by 2. Then quantity 1 minus 1.07 raised to negative 10. So it is 7256.5. Then B, find his remaining liability just after his sixth payment. So after the sixth payment, so it's the 7th up to the 16th payment. So F6 is equal to 6. So by the way, this is the present worth. Find the sum which he borrows. A over I. So A over 0.035, quantity 1 minus 1, 0.035 to the negative 16. Sorry. So 7256.7. Then find his remaining liability just after the sixth payment. So this is similar to problem 41-B, 41B, and it is equal to the value of the 7th up to the 16th equal payments. So 16 minus 7 is 9. Then plus 1, it's 10. So that's why we have here raised to negative 10. A over I, quantity 1 minus 1.035 raised to negative 10. So F6 is equal to that value. Then 41CC, just before his 9 payment, so it is F9 left. So it is equal to the value of the ninth value of the 10 up to 16. So 16 minus 10 is 6 plus 1, 7. There are 7 equal payments. Then plus $600. So F9 left is F9, which is equal to 600 over 0.035. So F9 plus 600, just like this idea here. Quantity 1 minus 1.035 raised to negative 7. That negative 7 is because it is just before the 9 payment. So it is the equal payments between the 10th and the 16th payment. So 10 minus 16 minus 10 is 6 plus 1. So that's why it's 7 there. Then plus $600. So 600 over 0.035, quantity 1 minus 1.035 to the negative 7 plus 600, and that is 4,200 something, 60 plus. And lastly, 41D, suppose that the debtor of problem 41C pays nothing until the end of 3 years. What should he pay then to cancel the debt completely? So since the debtor plans to pay at the end of 3 years, then that should be the value of the present worth, the money he borrowed initially, and it is equal to present worth times quantity 1 plus I to the n. So since I is 0.035, so it is, and the present worth is 7,256.5. So it is 7,256.5 times quantity 1 plus I 0.035 raised to 6, where 6 is 2 times 3. So F in 3 years is 7,256.5. This is the present worth. And quantity 1.035 raised to 6. So F3Y is $8,920. So that's it for this video.